Hello everyone, and welcome to this example recording on capacitor and inductor circuits. So the question that we're going to be attempting reads as follows. Determine the energy associated with the capacitor and the inductor. So we need to determine the energy of the 2 farad capacitor and the energy of the 0.5 Henry inductor. Right, so we notice in this circuit first that we have a DC source, which is a current source, and we've got the capacitor and the inductor. So we can redraw this circuit under DC conditions to see exactly what it will simplify to. And we know that under DC conditions, the capacitor will become a open circuit and the inductor will become a short circuit. And we are looking for that current, and we're looking for that voltage there. Why are we looking for the currents and the voltages? Mainly because of the equation for energy. We know that the energy associated with the inductor is a half Li squared, so we need current, and the energy associated with the capacitor is a half CV squared, so we need the voltage across the plates of the capacitor. Let's start with the current. So if I look at the flow of current in this circuit, I can see that current will come from the source. It should split in that manner, and we are looking for the current IL, so we should be able to use current division to say IL will be 4 over 4 plus 2 times 6, and this should give you a value of 4 amps. What about the voltage? The voltage VC, right? If you look at first let's take a look at the voltage from this point. We know that this is the ground point. What will the voltage from this point to ground be? Surely, because we know that the current flowing through here is 0, then the voltage drop across here must also be 0, which then means that the voltage there is 0, the voltage there is 0. The voltage from that point to that point is the same as the voltage from this point to that point, right? But then we see that there's a short circuit that's connecting these 2 points. So that is 0, that must be 0, that must be 0, and that over there is 0. And that tells us that the voltage across the capacitor must give you 0 volts. If the voltage is 0 volts, that then tells us that the energy associated with the capacitor, which is a half CV squared, is going to give us a half C times 0 squared, which gives you 0 joules. Whilst the energy associated with the inductor is going to give you a half Li squared, which is going to give you 0.5 multiplied by the inductance value, which is 0.5 multiplied by the current, which is 4 squared. So 0.5 times 0.5 multiplied by 4 squared, and that gives you a value of 4. So this gives us a value of 4 joules. Thank you for watching this video and enjoy the course.